In this video, we're going to talk about a fundamental object-oriented programming concept, which is encapsulation. Now, encapsulation is the mechanism that allows you to restrict access to certain components in the objects that you're creating. So you're able to protect the members of a class from external access in order to really guard against unauthorized access. Now, we're not talking security here, but we're stopping outsiders, in other words, classes or code outside of the class that you're working on, from accessing the inner workings of a class. So it can be very useful to hide that inner working from another class to sort of give you more control and to be able to enable you to change things without breaking code elsewhere. So let's go through an example of encapsulation. So what we're going to do first is we're going to create a class that doesn't use encapsulation to show you why encapsulation is a good thing. So we're going to start off with the class that doesn't use it, and then we're going to create an enhanced class that does use it. So let's go and create our class, and we're going to create a class called player, and we're going to model a player class as in a player in a computer game. So we're going to call this class player. As a standard public class, and let's create a couple of variables: public string name, public string health. So these three fields: public string weapon. We'll just say that in this game, these are the three fields that relate to the player's name, the player's health, how many hit points, in other words, and the player weapon. Now, you may have noticed, you may not have realized, I've actually used a public scope there. And we haven't gone into great detail about scope, but we have discussed it before. But we normally use private, but we're using public for a reason there, and that'll all become clear shortly. Now, we're not going to create a constructor, but what we are going to do is we're going to create two other methods. The first one is called lose health, and this would be called if the player lost some health for some reason. They fell off a cliff or they got damaged in some way. So we're going to pass a parameter called damage, and we're going to very simply put this dot health equals this dot health minus damage. And then we'll just do a simple bit of output, and I accidentally made that a string. That should have been an integer, so I'll just fix that. Actually, what I'll do there is I'll put if this dot health is less than or equal to 0, then we'll put something like player knocked out. And then here, which we're not going to do now, we'd put reduce number of lives remaining for the player. That's what we would normally do. So that's one method, and we're going to create another one, which is just going to return the amount of health that is available or that is remaining. We'll call that a public int health remaining. And that's purely going to return our variable this dot health, which is our field in this class. Pretty simple class, as you can see there. There's a name, there's the health, and there's a weapon that we can assign. We've got a simple method there, lose health, which would pass the amount of damage to it. Then if the total amount of health falls below or equal to or below 0, we were just going to print out a message to say the player's knocked out. And that's where we would normally put the code to reduce the number of lives and to check whether the game's over. So let's go back to our main class, and we'll create a new class. So we're going to start off by putting, and you've seen this before, player equals new player. We haven't created a constructor in here, and because we haven't created a constructor, if you recall, a default constructor with no parameters has been created for us. So we now need to manually set those fields, set the values for those fields. So let's try player.name equals Tim, player.health, let's say it's 20, player.weapon, let's say it's a sword. So that's our way to initialize those fields. And of course, as you can see, even though we're not in that class, we're able to access those fields directly. That's because we've set the scope here under public, or as public, for those fields. If we had to set those to private, we wouldn't be able to do that. And just to test it's working, let's put something like int damage equals 10, player dot lose health damage. And if we print that out, we'll put remaining health equals, and it should be player dot health remaining. So looking at that code, if we've started off with a player health of 20, we've got 10 damage, we've called the player dot lose health method, which actually reduces the damage, we should get some output here to say the remaining health is 10. So let's run that. And you can see remaining health is 10. So let's just make a bit more space here. And if we do another call, we'll put damage equals 11. And if we just copy these here, paste those in, and if we run this, remaining health was 10, then that was for the first call. The second call, the player got knocked out, and that was the code that was called from within the player class, and remaining health is now equal to -1, because 20 take 21 is -1. So that's obviously working, but I'm wondering whether you can see a possible problem here. We've created a method in here, lose health, which is our code that is going to manage the whole process of the player losing health. So this is where we put all our formulas for making sure that we're calculating damage correctly. And then if you can see here, there's a special message that comes out if the player's knocked out. You know, we might update something on the screen in a complex application. We'd want all our functionality to lose health to be called from that component in there. But the problem then becomes, first of all, we've got the ability to change the player health, but we can actually change the rules here. So we can put, just before the call to lose damage, we can put something like player.health equals 100, or say 200 there. So we're overriding that. So we're taking the control out of the player class. You can see there that it was meant to have been got to -1, but we've changed it, and consequently the player has got 189 health. So by being able to access those fields directly, you're really potentially opening up your application to be accessed in ways that you didn't want it to do, because you may not ever want the player to be able to change the health like that. You might want to control that process, and a good way of controlling the amount of health that we assign is with a constructor, for example. That's something that we've seen in the past. So that's one potential problem. It's the class that's calling this, the player class, is able to change those fields directly. But there's also another issue. So if we go back to our player class again, now let's just say that we've decided that we want to change the name here, the internal name. We think name doesn't make a lot of sense to us. We want to be a bit more clearer. We're going to change the name to full name. That's going to be the name that we're going to use from this point on. So this is an internal change, and in theory it shouldn't really affect any other class, because it's just the internal field name that we've defined that we think is a good name for this field in this class. But if we go back to our other class now, suddenly we've got an error, and it's quite rightly saying that it can't find that field anymore. Because we're trying to access these fields directly, we've got an error here. Now it's not the end of the world, but what it means is that any time that we change a function or something in here, change a name I should say, field, change the field name or something along those lines, we have to also make the change here. And in a small application like this, of course it's not going to be a problem, it's quite a quick change. But when you're talking about big applications, it does become a problem, because the first thing here, looking at this player, looking at the main.java, thinking is, okay, this name has changed. You have to figure out what's the new name. So you need to go back into the code and have a look and define and see what the new name is. So it's not really a problem as much when it's your code, but when you start using other commercial code, it's very, very normal for you to get given a library, a set of Java classes, and you're meant to use them. So it becomes a case of you, with this sort of design, having to figure out how that class works, which may not be something you want to do. The third issue with this approach is we might actually have forgotten to do this. Because we've actually put these names in manually, we might actually forget to actually initialize this altogether, and consequently when the class is called for the first time, it hasn't got any health. So in other words, we're not guaranteeing and ensuring that to access the player class, you can only access it when the data is valid. Now we can do that with a constructor. We can actually make sure that the data is valid and that you've actually got a valid class. But when you're giving control and getting people to manually get access to fields, there's no real way of us guaranteeing that the player health is set. And the other thing is, of course, we might want to have a method that is in our player class to define the maximum amount of health for a player. So we might want to have some validation. So we might want to go through a method, for example, called add health to make sure that they haven't selected a health that's greater than 100 or some other form of validation. And by allowing access at this level for people to actually just type in that directly, we can't actually call that validation. So this is what encapsulation actually does for us. This is why we don't want to code like this. We want the ability to be able to override these things so that we can make sure that the class that we're giving for access, that we're using for access, is actually valid, and that we've got more control over these things. So now you've seen some of the bad things, the bad ways of doing it. Let's actually comment this code out. And what we're going to do is we're going to create a class that actually has got proper encapsulation and show you the right way of doing it. So we're going to create a new class. We're going to call it enhanced player. So the difference is here, we're going to create our fields as private, a private string name, private int health, private string weapon. Next, we're going to create our constructor. And we're going to create a constructor with 3 parameters. Click on OK. And what we're going to do is we're going to define a default value of 100 for our health. And what we're going to do in here in our constructor, we're going to put a bit of code in. We're going to put if health, this is the parameter health, is greater than 0 and health is less than or equal to 100, then and only then are we going to actually assign the value to our field. So we've got some basic validation in there to ensure that the value of health cannot, well, actually I put 200 there, that should have been 100. So in other words, a value of between 1 and 100 inclusive is the only values that we're accepting for health. So you can see that now we've created just one constructor. So that, in other words, we're guaranteeing now that the name, the health, and the weapon are initialized when the class is created. Now we could put some more validation in there to check the length of the name for argument's sake, to make sure there's some characters in there, that it wasn't null for argument's sake, and likewise for the weapon. So in other words, we could do some other validation to make sure that it's valid. Now we can still create our lose health. That could still be the same method it was before. So public, in actual fact, just to show that, we'll just create, or just copy rather, the exact same method. Exactly the same as it was before. And we can also create a getter. Let's just create a getter for our health. Very similar to before, but we're just using a getter this time. So you can see already we're restricting access, because now if we go back to our, one class, we go back to here and we do enhanced player, we'll call it player again. Player equals new enhanced player. Well, now that we've got this, we have to define some parameters. So we're going to put something like Tim 50 sword. And just to make sure that that's working, we're going to do initial health is player dot. And notice we cannot access the field names directly, the fields directly, because we've assigned them as a scope of private. So we need to use the getter. So the getter is the only way that's giving us that mechanism to actually get direct access to the health. So obviously if we run that now, we should get the value of 50. So looking again at the code, we started with a default of 100. So when the field health is created for this class, when an object is created, the default value is 100. And if and only if the health is passed with a value of between 1 and 100 inclusive, will we update that. So first time we run this, we should get the value of 50 because it is a valid value in that range. Initial health is 50, but if we try and make something like 200, we should actually get 100. We're getting 100, and that's because this validation has failed because health parameter was outside of the values that we've signed there. In other words, it was greater than 0, but it was also greater than 100. So that's why that condition failed. So you can see straight away by doing it this way, we've got more control. We've got some validation which we weren't able to do if we weren't using encapsulation. And just to be clear, this is encapsulation. This is what we're doing is by making our fields private, we're making sure that our class is not accessible, or the fields within the class aren't accessible to any classes that are outside. So let's just say I wanted to change now the internal name for health. I could do that. I can click on that, and actually what I can do is show you a feature of IntelliJ that is really cool that enables you to do a quick rename. So you can actually click on what you want to rename, right click, go to refactor, then choose rename. And now if I go back and change this, the part that's in red, if I change that to hit points, notice how everything's changing on the screen as I type. I'm going to press enter. Pretty cool feature. And it's actually saying get a method found for the field hit points, rename the getter as well. I'm going to actually put no there, and I'll explain why shortly. So I'm going to click on no. Then the other thing, it actually comes up and says, oh, I've noticed you're now using the word health. Do you want to change that to hit points? So if I wanted to change it, I could just click on that and click on OK, and that would actually change these references that it's showing on the screen there. But I'm not going to do that, just to keep it consistent and just to explain why shortly. Click on OK. The point is I've now changed the field name, which was originally called health, to hit points. So internally we're now using the name hit points instead of health. But if we go back to our main class, we notice now we can still run this code and nothing's changed. Still it comes up with 100. And the reason is we're using the .getHealth method, and we've got no idea what the internal naming was for that particular field. We don't even know that we don't know anything about that, and we don't need to know anything about it. We're just calling this getHealth method, and it's doing the rest for us. So this is another cool feature in encapsulation, is we can make all these changes to this enhanced player class. We can create private fields and private functions that we don't want to be exposed to any other class, and we can change those names at any time in this code without affecting any other code. So that's really one of the huge benefits of encapsulation, is that you're not actually affecting any other code. It's sort of like a black box in many ways. What we're saying here is the only way to create an enhanced player object is to call the constructor with these parameters, and we've also got some validation in there. But the other thing is we can't also fake it now with the lose health, because we've got no mechanism to actually increase the health via any other means. We can pass the initial amount of health in the constructor, but we can't then fudge it like we did in the other class when we called that, when we set the value and then we actually changed the value midpoint when we shouldn't have. So we're giving all the control to the enhanced player class in this case, and in the case of losing health, we've ensured that no matter what, the only way with this class to reduce the amount of health for a player is to use this function. There's no other way for a class that's outside of this enhanced player class to access that. So this is why we want to be dealing with encapsulation. We really want to keep things confined and sort of reduce access, or protect is a better word. We protect the members of the class and some methods from external access. So we're doing that to prevent unauthorized setup or access. In this case, as I said, we're using it to make sure that the enhanced player, when we create a new object from the class, that it is valid, has got the right number of parameters, and they are initialized. But likewise, we're also making sure that there's no unauthorized access to the fields directly. So that's why you want to always use encapsulation. It's something that you should really get used to. You definitely don't want to be creating code like this where you're creating public fields. It's very rare that you'll need to do that. There are situations where you will want to, but generally speaking, you don't want to do that. You don't want to expose that access to other classes, because as you saw, it's more work to make those changes. When you create or when you change a field name or something of that nature, there's just more work for you to go back to all the other places, all the other code that's using it, to make sure that's changed as well. So that's encapsulation. In the next video, we'll go ahead and I'll issue with a challenge, and you can have a go at solving the challenge I come up with. So I'll see you in that next video.